teachers. We are so excited that you're looking at using our curriculum to support digital learning with your students. I'm Haley Huberty. I'm the Professional Development Manager here at Creative Learning Systems. We're going to go ahead and get started, and I'm going to talk to you a little bit about how to use this with secondary learners, so from 6th through 12th grade. When you get to the Launchpad, you are going to log in with the username ELearning and the password 2020. 2020. Once you log in, you'll get to the home page of the Launchpad. All of these circles we call nodes, and they're different groups of curriculum. So activity cards are designed for K through 2 learners. Express challenges are kind of quicker challenges for anywhere from 3rd through 8th grade. Liftoff challenges is the curriculum designed for 3rd through 5th grade. And then the rest of these down here are for middle school through high school students. And these are actually separated by our systems of technology. Our system of technology is grouped or kind of divided by the way that the technology is used. So for example, we have a technology called Stellarium that is an online kind of like planetarium simulation system. So it goes into scientific data because it helps students analyze the objects in our solar system and collect data about them and draw conclusions based on that. So that's just an example, but we have 5 different systems here that has curriculum that uses online resources that are free. So we've included it in our digital e-learning score. I also want to point out this orientation node. Here in the digital learning section, there is information about implementing our e-learning score. The information for the secondary students is going to be at the bottom. I'm going to open this up, but we'll come back to this piece because I also want to show you that we do have our webinars from our digital learning webinar series here. I'll continue to add recordings here as more webinars take place so that you have a resource kind of library available to you. I've also included links to the Google Drive folder that includes the PowerPoint slides and the additional resources, but these are really good for some best practices of digital learning and some resources that will help you implement it. There's also an ePortfolio setup guide that your students can use and an ePortfolio template that you can have your students use to document their learning. We'll go through this in depth a little bit. Later. I want to start with this e-learning score. So a score is what we call our scope and sequence. So it's the technology students are using. This includes the curriculum that supports those projects and utilizes that technology for the project, but it also has the sequence. Now it's pretty flexible though. So there's 6 different engagements on this e-learning score. 2 of them are 2-week engagements because they're slightly more robust and students can do a lot with those technologies. The other 4 are 1-week engagements. And students could either rotate through here from the beginning to the end. They could use it as a menu and choose what they are most interested in. You could have your whole class go through these engagements in the same order so that you have more students to serve as kind of experts. You have your whole class do Tinkercad and then have your whole class do Google Sites. You could also assign it to groups where 3 or 4 students, 4 or 5 students, depending on your class sizes, are assigned to each engagement. They each complete their own project, but then they have a couple other peers that can support them if they get stuck or have questions. So as you can see up here at the top, we have listed the systems of technology where they'll find the curriculum. That's going to be really important to teach them how to use either this score, or you could also just send out links directly to the curriculum. We recommend students choosing the curriculum that's interesting to them and best matches their background knowledge about kind of that concept or about that tool. For example, under Tinkercad, so Tinkercad is in computer graphics. That is the node or the circle that they would click on. It indicates the technology that they'll be using. how long it'll take, and a brief description. Now under here, this is a list of the curriculum accessible to them. So they can choose a level 1, level 2, or level 3. As you may imagine, as you go up the levels, there's less scaffolding. It's more open-ended and it uses the tool in a more complex way. So I would support your students in kind of choosing what is best for them, have them consider their background knowledge and also the project that's going to be interesting to them. If you see a really good connection to something that is already being covered in some of their other classes, like scale modeling and using math to support that, then you may want to assign that. But again, keep in mind the background that your kids are going to have and making sure it's appropriate for that. If they've never used Tinkercad before, hopping straight to a level 3 may be pretty challenging and could be frustrating in a digital space where they don't have you there to support them in quite the same way. It's going to be a little bit different. So just keep that in mind. But this is a resource for you to use to know what's accessible to them and potential sequence of how they could move through these engagements. So now I'm going to show you the curriculum that students would use. As I said before, they're going to be using these 5 circles to access the curriculum. I'm going to go into computer graphics since I was using Tinkercad as an example. So I'm going to click on Tinkercad. Once you get here, you'll then see the list of options for Tinkercad curriculum. So there's 3 different ones. Let's go into the level 1, but again, students can use the descriptions here to help them identify a project that's exciting to them. Once you get into the curriculum, you will start with your challenge. So there's the 4 tabs up here. Your challenge gives them kind of the objective for their project. So it's saying in this learning launcher, they will explore 3D drawing techniques, design their own 3D object, and then learn how to print it potentially. And there's, a video down here to get them introduced to Tinkercad. It also will tell them what they're going to learn and stuff they'll need. This is always a good starting place to give them some context. The next tab is the What You Should Know section, and this is all background information. So it's related to the technology, but also relevant content. So talking about vector drawings and vector versus bitmap, and just 3D printing in general. So there's a lot of really good career connections here as well to show students how this is used in kind of the industry. Students can read through this after the Your Challenge, or they can use it as a reference if they get stuck in the Do It section. So the Do It section gives them steps to get started with their project. So it's how to get into Tinkercad, access the tutorials, design a project, and then it gives them some ideas. So it's a place to get started, but then students have a lot of freedom to be creative and to design something that's meaningful to them. The Extend Yourself has some ideas for going to the next level with their project. So here, this is incorporating math to have them calculate printing costs. And it also has them look at some different projects to get ideas of something else they may want to create. There's career connections. Sometimes there's research opportunities or having them apply the technology in a different way. It's really designed to be nonlinear, but it's up to you and how you want to have students move through the curriculum. If you want it to be more linear, where they start with the challenge, then read the What You Should Know, and then do it, then it's just an expectation that you enforce with them. It can be part of the instructions for kind of the daily assignment you give them. Totally up to you and what is going to be best for you and your students. I want to show you the e-portfolio that students can use to document their learning because it's a really good way to break down the project into daily assignments. And the e-portfolio models our project cycle. So when students are working on a project in the SmartLab, which is what we call our learning spaces, they go through this EPDRS project cycle. So the first section is where they're exploring, and it really is just exploration with the tool, figuring out how it works, what it might be used for, what it can do. And so this slide has a place for them to jot down some questions they have about the technology that can guide them through their exploration, and then they can jot down what they learned about it. The next section of our project cycle is planning, and this is so important. Our challenges are very open-ended intentionally to give students the opportunity to make it meaningful to them, and that's where the SMART goal comes in. So they design a SMART goal that is specific, measurable, attainable, relevant, and time-based. And this is where they can customize it, where they may say, I'm going to create a 3D object that is going to be a controller for my robot vacuum because it always bumps in to my door. Whatever is going to be helpful for them and is going to be interesting and meaningful. So this is super important. It also gives them a purpose and kind of a driving force behind their whole project. The next section is where they actually write down their SMART objective for their project. This can be pretty challenging for students, especially the first time. So I would recommend providing a little more guidance for this or check-ins so that you can help them write a good SMART objective. You could also do the first engagement together as a class where everyone is working on the same project and the same learning launcher. And then you can kind of design a SMART objective together with a component that is more personalized to what they actually want to create. But that support can be really helpful so they're successful right off the bat. The next section is Do It. And Do It is going to last for 2 days. So they spend 1 day exploring, 1 day planning, 2 days doing their project, and then we'll get to the last section. But also with doing is reflecting. Students are constantly, as they're creating, reflecting on their plan, reflecting on the resources they need, how they're doing, and correcting course if they need to. So here there's spaces for them to document what they did, what they learned, and how they problem solved a challenge. Because there is going to be a lot of problem solving in this process. Our curriculum is designed so that it is not step by step. Students have a lot of creativity and they're going to be figuring out how things work. And we intentionally don't provide all of the answers because we want them to figure that out. The second day of Do It, students are focusing more on what they learned and how they know. So pulling evidence from what they learned about their technology and how it works. There's also space for them to document about how it's used outside the classroom. So making that real world connection and how it can be applied, not just in your class, but to kind of for the better good or in their lives outside of school. The final section that would be done probably on the 4th day, maybe the 5th day at the beginning, is reflecting on their work. Really looking back at the process and thinking how they managed their time, whether they met their objective, what challenges they faced, what they would do differently. Those are really good questions to get them reflecting on their work and potentially making goals for their next project. The final step in our project cycle is share. And it's not on the slides because students aren't just going to share within a slide. Going to be sharing, via video and what was most meaningful or what they're most proud of from their project. It may be sharing it with someone who would want to purchase this prototype, so a stakeholder or a relevant audience. As you design the sharing piece, think about what's going to be engaging and meaningful to your students. In this digital space, it can be pretty isolating, and your students are probably missing their peers and interacting with their peers. So an opportunity to see each other face to face, whether that's virtual presentations using Zoom, so students can share their screen and show what they created, or if it's using Flipgrid to have them record what they did, all different ways that you can share, but it's definitely an essential component. You can use this project portfolio to help guide students through the process, break it down into smaller chunks, and have some accountability. It's also customizable, so when you make a copy, if there's other components you want them paying attention to and documenting, it's totally up to you, and you can build those into this e-portfolio. Again, the orientation resources and digital learning will continue to build. You will likely want to use this ePortfolio setup guide with your students to have them set up their first ePortfolio. You could also share it out through Google Classroom or Schoology. or just by email. Send them a digital copy of the slides and have them send it back when they're done. As you get started with SmartLab learning with your students, please don't hesitate to reach out to us with any questions or additional requests. We're continuing to make resources that are helpful, so keep an eye on the orientation section, but also let us know if there's anything else we can do to support you. We're here for you, and we want to be a resource in this challenging time. So you can always email us at academics@clsonline.com. Again, that's academics@clsonline.com.